Hello, welcome back to all. Today we are discussing the topic of salinity. Salinity is the total content of dissolved salts in seawater. It is usually expressed as parts per thousand or ppt. The average salinity of seawater is about 35 grams per kilogram of seawaters or 35 ppt. Ocean water salt composition: 77.7% sodium chlorides, 10.9% magnesium chloride, 4.7% magnesium sulfate, 3.6% calcium sulfate, and 2.5% of potassium sulfates. Factor affecting on motion salinity: evaporation. Evaporation increases and precipitation decreases the salinity. Examples: Mediterranean Sea, Red Sea. The Red Sea receives very little precipitation in any form. Also, no water enters the Red Sea from rivers. Decreases in coastal region by the freshwater flow from the rivers like Ganga, Brahmaputra in the Bay of Bengal compared to Arabian Sea. The salinity is less in Bay of Bengal. In polar region, by the process of freezing and melting of ice, while ice freezing the ice, it will increase the salinity, and melting of ice will reduce the salinity. Wind influence salinity by transferring water to other areas. Ocean currents: warm current evaluate salinity in higher altitudes. Cold current decrease salinity near the equator. The salinity of the North Sea increases due to more saline water brought by the North Atlantic drift. Water mixing and enclosed sea. Limited freshwater mixing increases salinity. Example: Black Sea, Caspian Sea, Red Sea, and Persian Gulf have high salinity. Salinity, temperature, and density of water are interrelated. Any change in temperature or density influence the salinity of water in highest an area. Salinity in water bodies: Lake Van in Turkey 338%, Dead Sea 238%, Great Salt Lake 220%. Horizontal distribution of salinity. The salinity of the normal open ocean ranges between 33% and 37%. In general, salinity gradually decreases towards the poles. Equatorial region have higher salinity due to evaporation, but this is countered by precipitation. Subtropical high pressure zones experience the highest salinity due to high insolation and low precipitation due to subsiding winds. Polar region and mid latitude have lower surface salinity, high in landlocked sea like Red Sea, and there is not much mixing of water, and in hot and dry regions where evaporation is high. Salinity decreases in the western parts of the northern hemisphere because of the influx of melted water from the Arctic region. Vertical distribution of salinity. Salinity generally increases with the deep and with depth, and there is a distinct zone called the Holocene. Compare this with thermosaline, where salinity increases sharply. Salinity at the surface increases with the loss of water to ice or evaporation, or decreases with the input of fresh water. Lower salinity water rest above the higher salinity dense water, leading to stratification by salinity. Salinity changes with depth, but the way it changes depends upon the location of the sea. High latitude increase with depth, middle latitude increase up to 35 meters and then decreases. Equator surface salinity is lower due to high precipitation and low evaporation due to the cloudiness. Salinity of marginal seas, North Sea, in spite of its location in higher latitude, records higher salinity due to more saline water brought by the North Atlantic drift. Baltic Sea records low salinity due to the influx of river waters is largely quantities. Red Sea has high salinity due to high evaporation and limited freshwater input. Mediterranean Sea records higher salinity due to high evaporation. Salinity is, however, very low in the Black Sea due to an enormous freshwater influx by rivers. Bay of Bengal has low salinity due to the influx of river water. On the contrary, the Arabian Sea shows higher salinity due to high evaporation and low influx of fresh waters.